Okay, so today we start Unit 3, which is our dosage calculation unit. This is probably, for as far as immediate need, the most important section of the course for pretty much all of you. All of you are in programs with a paramedic or ADN that are going to heavily require dosage calculations. So this is the section, we get an extra day in the fall because we don't lose Friday for Easter weekend. So this is the section that we take that extra time in, and we kind of slow down and really go into the details and the examples of these calculations. For this section, we're going to be using a lot of calculations that involve medications. Just because I am not a medical person, definitely not an expert on medications, we're going to use the generic term serum. That's going to refer to any sort of a concentrate. So that could be a pure medication. Could be some sort of a other product like rubbing alcohol, pure hydrogen peroxide, something like that. It's not a medication, but it has some sort of usage. Or it could be some sort of a bodily fluid. Urine or blood mostly when we're dealing with that. So the serum refers to the item that is medically important to us. Then we have, of course, something that's being mixed with. That is generally some sort of a sterile water. Could be sterile water, could be a saline solution. Just water with a few things added to it to pH balance it. Or some other form of a neutral solution. In other words, a solution that has no medical benefits to it at all. And we're going to refer to this simply as NS throughout the course. Normal saline or neutral solution. In any case, whenever you see that abbreviation NS, all it means is something that has no medical benefit. It's there to dilute the medication or whatever other item we're working with, and to carry it from vial to patient or into a testing meter of some sort. So obviously we're going to be dealing with solutions here. And in that last unit, we dealt with solution mixtures. And one of the things we saw there was our formula that said the amount of that active ingredient is equal to the concentration times the volume of the whole solution. That volume was the total solution. The amount was our active ingredient. In terms of what we're talking about in this unit, that would be the serum. So a simple review, if we had 200 milliliters of 18% solution, is 0.18, 200 milliliters. That gives us 36 milliliters of our serum. Well, today we're going to look at another way of discussing not the concentration, but the mixture of serum into saline rather than just using a percent or concentration. That is something called a dilution. And a dilution is nothing more than a ratio. It goes back to what we learned about ratios in the last unit. Remember, a ratio just compares two numbers. And in a dilution, we're comparing the amount of serum in a solution to the total amount of solution. So if I mix 40 milliliters of medication, serum, in a 250 milliliter solution. 250 milliliter solution, that is the total solution. That's 250 milliliters. 40 milliliters, that's the medication. Reduce that, of course the milliliters cancel out. 40 and 250 can be reduced, both divide by 10. And then 0, so we can divide by 10, that gives us 4 over 25. And that's as far as we can reduce that as far as ratio is concerned. So that would be referred to as a 4 in 25 dilution. For every 4 parts of serum, we have 25 parts total solution. So what that means, let's say we have a 1 in 6 dilution of alcohol and water. What that is saying is we have ratio of 1 to 6, where the 1 stands for the parts of serum. In this case, that serum is alcohol. And 6 parts solution. So using that, let's ask how much blood would be in 2-in-7 dilution of blood in water, NS, if it is 280 milliliters. So we work with our dilution. It's a 2-in-7 dilution. So that is a 2 to 7 ratio. I know it gets a little tedious and redundant to keep labeling these parts, but for now we're going to keep doing it. The 2 represents parts of serum, in this case parts of blood. 7 parts total solution. Working with ratios, we're probably going to set up a proportion On the other side of this proportion, we got the 280 milliliters. Does that represent the blood or the total solution? Solution. So the 280 milliliters goes on bottom. Now we'll solve. We'll cross multiply and divide. 2 times 280 divided by 7 is 80 milliliters. So you would need 80 milliliters, or there would be 80 milliliters of blood in that solution. Now, similar to that, how much of a 1 in 5 dilution of alcohol, water can be created using 42 milliliters of alcohol? So we have a 1 in 5 dilution here. So 1 again is the part serum, in this case the alcohol. And the 5, of course, is still total solution. Do we have the total solution? No, we have 42 milliliters of alcohol on top. We want to know how much of that dilution. When we're asked how much of a certain dilution, that is asking how much total solution. The dilution itself is referring to the total solution. So we'll cross multiply. 5 times 42 is 210 divided by 1 is 210 milliliters. So we can create 210 milliliters of that 1 in 5 dilution using 42 milliliters of alcohol. Now, when we talked about ratios, we talked about the fact that every ratio has hidden parts to it. Here in that 1 in 5 dilution, there were 5 parts total solution. And we said
a little bit to the last one for just a second.
Sure. Go.
So how did you get that second part of the fraction?
Over here?
Yeah.
Okay, so 1 represents alcohol, the parts of alcohol. The 5 represents the parts total solution.
Yep.
But our problem, we're given 42 milliliters of alcohol. So that matches up with the alcohol, so that's why the 42 goes on top.
Okay.
Milliliters. Find this number down here. When we have a missing number in a proportion, we take the 2 numbers that are diagonal. 5 and 42 are diagonal. We multiply those together. That's 5 times 42 is 210.
Okay.
Then the other number that's diagonal with the missing number, we divide by that number. 210 divided by 1 is just 210. And our units have to stay milliliters.
All right, thank you.
Bet. So in that 1 in 5 dilution, we had 5 parts total solution. And we said that one of those parts was our serum, in this case alcohol. So the question I pose is, what are the other 4 parts? That is that sterile water, neutral solution, called NS. So in that ratio, that dilution, 1 in 5, it's implying 1 part alcohol in 5 parts total solution. Saying 1 part alcohol and 5 parts total solution. But implied in there is if 1 out of the 5 parts is alcohol, the other 4 out of those 5 is that normal saline or neutral solution. So if I give you, we have a 3 in 8 dilution. There are actually 3 ratios that are important to us here out of that 1. The first is the dilution itself, 3 in 8. 3 represents the parts serum, and 8 is the parts total solution. But the second important ratio to us is NS, the total solution. That ratio, of course, total solution, there's still 8 parts of total solution. How many of those parts is NS, saline? 5. 8, there's 3 parts that are serum, so 8 minus 3 gives us 5 parts for saline, neutral solution. Then, of course, the third important ratio we get out of here is the ratio of serum saline. Once we've got the other ratios created, this one's obvious. Serum is still 3 parts, and we said saline is 5 parts. Why is this important? Well, because we'll be given the dilution, but in some cases we're not looking for the serum, or we're not looking for the total solution. You might ask, how much NS is needed to create 200 milliliters of three in 10 dilution. Well, remember 3 in 10, 3 is the serum, the 10 is the total solution. We want total solution. We have the 200 milliliters, that does represent the total solution. But we don't want the serum. Now we could find the serum and subtract that from the total solution. But it's much easier to just adjust our ratio. Get the ratio of the saline to total solution. What's that ratio going to be? 7 to 10, perfect. 3 out of the 10 parts are serum. The other 7 out of the 10 parts are saline. $200 we said was total solution, so that's going to go on bottom. 100 milliliters. 10 is also total solution. Then we'll cross multiply and divide. So the numbers that are diagonal are the 7 and the 200. 7 times 200 milliliters is 1,400 milliliters. 10 is diagonal with our missing number, so we're going to divide by 10. It's 140 milliliters. So it takes 140 milliliters of saline to create 200 milliliters of that 3 in 10 dilution. We might ask, how much saline should be mixed? 80 milliliters of, butcher this, amoxicillin create 2 in 9 dilution. So again, the dilution is 2 in 9. 2 represents serum. In this case, that's the amoxicillin. 9 is the total solution. What we're working with here, do we either have the amount of the amoxicillin or looking for the amount of amoxicillin? We have the amount of amoxicillin, 80 milliliters. So we have that. That's what we're going to need. We're going to keep that. Do we have the amount of total solution? No, we don't. Are we looking for the amount of total solution? No. We're looking for the amount of saline. So this is not the ratio we want. We want the ratio, we want to keep the serum, in this case the amoxicillin. We want to know how much saline that's related to. So what would this ratio be? 7 is the amount of the saline. We still have 2 parts serum, right? So it's a 2 to 7. There's 2 parts, still 2 parts of amoxicillin. Instead of comparing it to the total, we want to compare it to the rest of it, which is 7 parts of saline. So we have 80 milliliters of amoxicillin. That goes, the amoxicillin, 80 milliliters, and we cross multiply and divide. 7 times 80 is 560 milliliters. We'll divide by the 2. Giving us 280 milliliters of saline that should be mixed with that 80 milliliters of medication. So I might ask, how many milliliters of saline should be mixed with 200 microliters medication create 1 in 12 dilution. It's 1 in 12. Remember, the 1 represents the medication, the serum, and the 12 is the total solution. We have the serum given, 200 microliters of medication, so we want to keep the serum. We do not have the total, and we're not looking for the total. We're looking for the amount of saline. So once again, we want that ratio that compares the serum to saline. What's that ratio going to be in this case? 1 to 11. 12 minus 1 gives 11 parts saline. We still have 1 part serum. Now you may have noticed I asked for milliliters and I gave microliters for the medication, which doesn't affect us in this next step at all. It just means we have an extra step to do at the end. We still put 200 microliters in for the serum, and we are still going to cross multiply and divide. 11 times 200 is 2200. Divided by 1 is still 2200. What units go on this? Microliters, as we discussed a couple weeks ago. Whatever, in a ratio, whatever units go with one number, we have to have the same unit on the other number. So if one is microliters, the other one is microliters. Now is where that extra step comes in, because we wanted milliliters. Change microliters to milliliters, 1,000 microliters in a milliliter, or 3 decimal places. You have to move 1, 2, 3 decimal places. 2.2 milliliters. Any questions? I'm gonna have you try a few in your notes. How much medication? Required to create 240 milliliters of 3 and 8 dilution. First one.
Saying 3 and 8.
What's that?
140.
Your face is over half the equation.
Okay, my face is up in the top corner now. Okay.
Yeah, there we go.
Yes.
Thank you.
Usually it's down in this bottom corner, so I'm used to avoiding that. But I can see the format is different. I can see on the back screen. I'll try to stay low for you. The second one I'll put up here is, now let's do this. Find the dilution created. If 400 microliters serum mixed with 20 milliliters of saline. I'll give you guys a minute or so to work through those, and then we'll go over them. Let's take a peek here. So the first one, 3 and 8 dilution. Remember, the 3 is the serum, the medication, and the 8 is the total solution. We have the 240, which is the total solution. We have, or we're looking for the amount of serum, so the medication. So the 240 milliliters goes in for the total. This is the ratio we want, because it has what we have and what we're looking for. We'll cross multiply and divide. 3 times 240 divided by 8 is going to give us 90 milliliters. So it would take 90 milliliters of serum to create 240 milliliters of 3-in-8 solution. Dilution. The second one, what dilution is created? So remember, the dilution is serum total. You put in 400 microliters of serum and 20 milliliters of total. One of these has to be changed. Really, at this point, it's a matter of personal preference, which one, how you want to reduce it. 400 microliters would be 0.4 milliliters. That can be an awkward reduction with the decimal in there. You'd have to multiply by 10 to move the decimal point over. Or 400 microliters can stay there and turn the 20 milliliters into microliters, which would be 20,000 microliters. Neither one of them is a real happy reduction. But to me, it's always easier to start with large numbers and reduce down than it is to have to get rid of decimals. Both of these, by the way, are divisible by 400. 400, and of course the microliters will then cancel out. 400 divided by 400 is 1. 20,000 divided by 400, is that 50? So we get a 1 in 50 dilution. I don't remember where my edge is here, so I'll try not to write behind my face there.
I can hide your face.
You can hide it? Thank you.
Yeah.
You don't want to look at me anyway, right?
Okay. No.
There we go, thank you. So how much iodine and how much NS are required to create (550 milliliters) 4-in-11 dilution? Well, we have a 4-in-11 dilution. 4 is the serum, in this case the iodine. The 11 is total solution. Now what we want here is we want the iodine, the serum, and we want the saline. Unfortunately, the only amount we are given 550 milliliters of the dilution. That is the total solution. So we have to keep the total solution in our ratio here, which means we're just going to have to do 2 of them. So we keep the 4 and 11. The 550 milliliters goes where? Bottom. So that is our total solution. Cross multiply and divide. Four times 550, 2,200 milliliters, divided by 11 is 200 milliliters. And of course, that represents the amount of iodine. Now, there's 2 ways we can go about finding the amount of saline. The simplest way would be to just subtract. Put a number back up there that disappeared. We can simply take the 550 and subtract that 200. But I'm going to go ahead and I'm going to use that ratio of saline to total solution. There's still 11 total parts here. How many parts of them are saline? 7. 4 out of 11 are serum. The other 7 out of the 11, saline. We set it up the same way. 550 milliliters is still the total solution, and you still cross multiply and divide. Now it's 7 times 550. 1,850. Divided by 11 is 350 milliliters. So it is 350 milliliters of saline. Any questions there? So in your notes, how much of a 2-in-7 dilution can be created using 120 milliliters of saline and find the amount of blood and the amount of saline needed to create (270 milliliters of a 2-in-9 dilution. Give you a minute or two to work on those, then we'll go over them. So for number 1, we have a 2-in-7 dilution. Remembering that the 2 represents the serum, 7 represents the total solution. We want to know how much of a 2-in-7 dilution can be created. That is the total solution. So we want that. But we're using 120 milliliters of saline. So what we want the ratio of saline to total solution. What's that ratio going to be? 5 to 7. Good. You still have 7 total parts. If 2 of them are serum, the other 5 are saline. $120 milliliters is saline, and we're trying to find the total solution. So cross multiply and divide. 7 times 120 divided by 5 gives us what? 168 liters of total solution. Number 2, find the amount of blood and NS needed to create 270 milliliters of a 2-in-9 dilution. 2-in-9, remember the 2 is the serum, in this case blood. 9 is total. Creating 270 milliliters. Find the amount of blood needed, we'll cross multiply and divide. 2 times 270 divided by 9 is 60 milliliters. Then create the ratio of saline to total. 7 to 9. $270 milliliters of total solution. Cross multiply and divide. 7 times 270 divided by 9 is 110 milliliters of saline. Now, of course, you could have just subtracted total of 270 minus 60 to get the saline. I like to figure them both out and make sure they add back up. Those do add back up to 270. It's just me being cautious. Okay, now we're going to shift gears ever so slightly here. Still discussing a dilution, but we're going to tie it in with concentration. Find the dilution required to create 120 milliliters of 25% solution. Well, we have 120 milliliters. That is our total solution. We have our formula that active amount, in this case the serum, is equal to our concentration times our total volume. So we have a concentration of 0.25 times that total volume of 120 milliliters. We multiply that, gives us 30 milliliters of serum. Now it's just a matter of creating our dilution. Remember the dilution from the total. 30 milliliters of serum over 120 milliliters of total. Now I occasionally get asked, why do you put the milliliters in there? Why do you put the units in there if you know that's just going to be canceled out right away? First step here of reducing it. I put them in to make sure they can be canceled out. Remember, we've had problems where we mixed microliters with milliliters. I want to make sure that they are the same units. And then, of course, once they are the same units, we are just going to cancel them out. Of course, both of these numbers, 30 and 120, can be divided by 30. Give us 1 to 4. So a 25% solution is a 1 in 4 dilution. There are times where that is going to be easier to use than the percentage stuff. Okay, we've got a couple minutes left. Anybody have any questions? Okay, so the page we're working on here today is page 130 to 132. 1 through 37, the odds. Anybody who still needs more time to finish up the test, please feel free to stick around and finish that up. You guys have a great weekend. We'll see you next week.